So this is your test review. Hopefully you've had a chance to work through it. Again, the version online is may not exactly be like this. It may or may not. But if you work out the one online, it's just practicing the same problems, just different numbers, so you can get an idea. And I'm not going to record it as a grade that counts against you. So, work through it as many times as you need to. And when you feel comfortable with the information, if you take it a couple times and you feel like you've done pretty good, then you should do pretty good on Thursday. All right, let's look through these, though. I know the answers are on here, but I can kind of explain why, hopefully. So number one, identify the population being studied. And the scenario that's given is the heights of 14 of the 31 cucumber plants at Mr. Leonardo's greenhouse. And we want to know what the population would be. So, the population is every, person, everything that's being studied. So that will be all of the cucumber plants at his greenhouse. And you can see it says all cucumber plants at greenhouse C. All right, determine if the numerical value describes a parameter or a statistic. Remember, parameter goes with population. Statistic will go with a sample. A recent poll of 1,373 corporate executives showed that the average price of their car is $32,200. So this poll of 1,373 is a sample of all corporate executives. All right, it's not every corporate executive that there is. This is just a sample. So that would mean that this would have to be a statistic. All right, sample statistic. Number 3 says, determine whether the statement describes a population or sample. The number of times the students on your floor order Chinese in a week. So the students on your floor, that would be the population. Okay, so the number of times that they order Chinese in a week would be like a parameter, so population. All right, see population. Determine if the numerical value describes a population parameter or a sample statistic. The average price of a house in the new subdivision is, so we're talking about all the houses in a new subdivision. This gives the average price of all the new houses in a subdivision. Not every subdivision ever, just all the new houses in a subdivision. It's $257,000. So that new subdivision is what we're basing that number off of, and that includes every house in that subdivision. So that would be a parameter, population parameter. All right. Number 5, fill in the blank with the most appropriate term. A company did a study on the physical activity level and weight gain of its employees. Age was not considered. So it might be an example of, all right, so if you have an outside variable like age that could affect the study, then that's a confounding variable. All right, so that's why it's confounding variable. Because, again, age wasn't considered, but your age, with age, metabolism slows down. Enjoy now being able to eat anything and not gain a lot of weight, because one day it may catch up with you. All right, number 6, an experiment in which the only participant does not realize whether they receive a placebo or a treatment in which only the participant does not realize. So the person given the experiment realizes it, but the person receiving it does not realize it. That would be single blind experiment. If the person giving it and the person receiving the treatment don't know, then it's a double blind experiment. But if I'm conducting an experiment and I know whether you get the placebo or not, then it would be single blinded, because I know one person doesn't know. That's you. I know, so it's single blinded. If we both didn't know, it'd be double blinded experiment. Does that make sense? All right, number 7, determine whether an observational or experimental study is appropriate to address the following statement. Our car wash operator wants to find out the average age of his clientele. All right, so in order to do that, the car wash operator is going to have to observe whoever's going through the car wash, right? So that's an observational experiment or an observational study, because they're observing. They're not introducing something into the people that are given the car wash, or that are, having a car wash. Number 8, letter grades on a test are an example of what kind of data? Continuous, discrete, neither. Well, letter grades, that's going to be nominal or ordinal, right? It's one of those two. So it's not discrete or continuous. It has to be interval or ratio data to be continuous data or discrete data. So that's why it's neither. So it's labels. So if you have labels, whether they can be sorted or not, if it's labels, then it's not going to be discrete or continuous. But if it's numbers, so if it's interval or if it's ratio, then it can be discrete or continuous data. Because how do you really, if you think about those types of data, countable, no holes, if it was averages, then yeah, but not letter grades. If it was a set of data that's letter grades, even though we can rate those, so that would be ordinal data, because you can rank letter grades, A through F, but we don't really consider there to be a gap between A and B, even though there is. We don't know the gap because your A and my A may be different number ranges. So that's why it's neither on that one. If it wouldn't have said letter grades, if it just would have said grades on a test, then it could be countable, so then I would say it would be discrete. It wouldn't be continuous because there's gaps between a 94 and a 95, right? Anyway, hopefully that's not too confusing. Number 9, pounds gained by persons in your class during the first month of the semester are an example of which type of data? All right, so the number of pounds gained, if you think about it, if it's a number and it's countable, right? Like that freshman 50 everybody goes through, then it's quantitative. All right, so what type of data is it? It's quantitative. Quantitative. It's a quantity. It's a number that you gained or lost in the first month of the semester. All right. Number 10. Classify the data, indicate whether the data is qualitative or quantitative, indicate whether the data is discrete or continuous or neither, and indicate the level of measurement for the data. Remember, if it's nominal or ordinal data, then it's not discrete or continuous. So let's see what kind of data it is. The ranking of 3 books on the New York Times bestseller list. Okay. So we could rank them maybe by their performance, like if they're first, this is the best selling, the very best, number 1 or number 2 or number 3. We could do that, right? So even though they have labels, they could be ordered somehow, even though we wouldn't really say first minus second or anything like that. So since they're labels, it's either nominal or ordinal. But since they can be ranked, that means that it's what? Ordinal, right? Now, since the rankings of the books would be like labels, you come in first, you come in second, you come in third. And that means that it has to be qualitative, right? So qualitative data that can be ordered is ordinal. So it's qualitative, it's ordinal. I'll skip the second question. Are these data discrete or continuous? Neither. Because if it's nominal or ordinal, it can't be discrete or continuous. All right. All right. Number 11. In order to help decide when and where to advertise, an outdoor equipment repair company decided to pull invoices and tally what types of power tools were repaired. So they're using the tally method like I showed you. There were 25 power tools repaired that month. Construct the frequency distribution for the data. All right, so I'll show you how I would do that. I would first make a table kind of like this. I'm just going to cut off part of it. So I'd make a table, and it would of course have to say power tools or whatever at the top. All right, and then this is where I put my frequency out here. And if I tallied those, that would mean that I go through, and for each one of them, I'd put like a tally mark whenever I see one of those in the list. So let's count up the leaf blowers. Let's see. I mean, you can put tally marks, but there's not very many here, so you could probably just count them. Let's see, 1, 2, 3, 4, 5, 6. So make sure you check my answer because I might be wrong. 1, 2, 3, 4, 5, 6. Did y'all count 6? All right. So then I'd put 6, and then wait. Did I look at leaf blowers first? What about I guess let's see. Let me go back. Power tool and frequency. Okay. Yeah. Power tool is like the category. So this is just labeling this, telling you its frequency. All right, pressure washers. Count up those pressure washers. 1, 2, 3. I counted 7. Push mowers. Counted 6. Riding mowers. Three? Is that what you got? And what about weed eaters? Was it 3? Okay. So you just look for the answer that has that. I mean, it's not very complex at all. Just look for, which one of these has those exact numbers. All right. A local car dealership keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percentage of the complaints are due to the category body paint defects? Round your answer to 2 decimals. So it wants to know a percentage, and we want to round that percentage to 2 decimals after we change it to a percentage. So body paint defects 19. We have to know how many total there are. You already added them up. It was 192. All right, so if you add all these up, you get 192. And we were looking at the body and paint defects, then it would be 19 divided by 192. Now that gives you the decimal. You change that over to a percentage and round to 2 places. All right, so if I change that to a percentage, it would be what? 9.8958. So $9.8958. It says to round to 2 places. So that would round that up to what? 9.90%. So that's your answer. I noticed on the answer down here they just put 9.9. That's fine with me as well. You can put 9.9% or 9.90%. It means the same thing. Alright, looks like the next problem is exactly the same except different categories. Plain interior looks shabby or tickets cost too much. So we're going to have to look at plain interior looks shabby, and it says or, so we have to add that and the tickets cost too much together. So 8 and 26, that's going to be what? 34. So we're going to say, let's see, this is number 13. We're going to say 34 divided by the total number. So we have to add those up. Somebody did that. 151. Again, just take a calculator, divide, and then we're going to round to 2 significant digits. So that would be 22.516. So 516 would become 52, right? So that's going to be about 22.52%. Again, you move your decimal place over 2 places and then round to 2 places. All right. Number 14. The following bar graph shows the per capita personal income for 6 states in 2004. Use this bar graph to answer the questions. All right, find the lowest per capita personal income for the 6 states shown. So it'd be the one that's lowest, right? That's how you find the lowest. And that would be Arkansas, so 25,725. Step 2, find the highest income. That would be the bar that's the highest, 51,803. And then it says construct. Oh, wait, that's it. Never mind. All right, that was number 14. Number 15 says construct a bar graph that represents the following data regarding the game scoring per game scoring average by NBA player. All right. Determine the missing value on the vertical axis. So this is the vertical axis. If that's 0 and that's 30, It looks like this one's halfway in between, right? So what's that going to be? It has to be 15. So each one of these tick marks would be 5. So that'd be 5, 10, 15, 20, 25, 30. So the answer is 15. All right, look at the next one. If this one is 30 and we figured out each one is 5, then what would the next one have to be? That's right. If the one in the middle was 15, one more tick mark up has to be 20. Create the bar graph representing the data. I may have to take that one off if you're not working it online. It really depends on, I guess if you had this space up here, you could create it, right? Like you could take, for number 3, I think online what you can do is actually click on it and create it. But if I give you this space up here for number 3, let's see. Then all you would need to do, if we create one for Carl Malone, let's just say for Carl Malone, and it's 25.5. So we know 25 is 5, 10, 15, 20, 25. We just go up just a little bit more because 0.5 means, you know, it's not quite 26. Alright, so I could create a bar graph like that for number 3. And then it says create the bar graph for Eddie Jones. What did how much did he do? Eddie Jones 20.1. So then you could just in the same space, if you're doing this, if you're doing a calculator, you can click on it and do it. But if you're doing this in the same space, you could just maybe see, that's 25, so that's 20. So we could do one kind of like that. That's for Eddie Jones. Okay, so it's not too hard to do that. And since, if you're doing this out by hand, I'd probably just put it on one of these graphs since it didn't give you something to put it on. Just put it on the one for step 2. That's what makes the most sense. Well, down here, complete the bar graph by labeling the remaining bars. So I guess that would mean we'll just create the other 3. That will be step 3, step 4, and step 5 would just be to create the other 3. So I guess you could do all of those at once. They leave a little space here. It really doesn't matter to me. As long as each one of these are the same width, that's all that matters on that one. Alright. Alright, number 16. Alright, so it says this place sells about 810 books each month. And it tells here the percentage of each of the types of books that it sells. Find the number of cooking books sold each month. Round your answer to the nearest integer. So I guess we'll just round up on all of those. I'm fine with you just round. If it says round to the nearest integer, just rounding to the nearest integer is fine. I'll count either problem correct, whether you round up or round down. Not round down, but keep it the same. Because it's not very specific in the directions. But 810 books, and we're looking for cooking books. So if we take our calculator and we say 810 times, so cooking books is going to be 17.7 written as a decimal, is 0.177. All right, so, if you wanted to round that, I'd say 144 because you can't have 143.37 books. But if you want to round it just to the nearest integer, remember we worked one problem where we rounded it correctly and it gave us the wrong answer. But if you want to round it to the nearest integer, then that would have been what? It was 880. That was the wrong number. It was 810 times 0.177. So you could just, if you rounded it to the nearest integer, you could do 143. Again, I'm fine with 143 or 144. If I'm grading this by hand, I'll give you credit for either. If you're doing it on the in the computer, then I guess I want you to put 143 to the nearest integer. I just know we were working one like that and it gave us the wrong answer one time. Find the number of romance books sold each month. Well, that's easy. So the number of romance, 38%, so it's 810 times 0.38. So that should be 308 if you round to the nearest integer. The number of travel books, you do the same thing. I'm not going to do all of these. That'd be 810 times travel would be 0.16, get 130. The number of nonfiction and number of mystery books, do the same thing. Just multiply by the percentage. Well, by the decimal that represents the percentage. All right. The following data describes percentages. Describes the percentage of satisfied customers at Joe's Used Cards. Complete the frequency table for this data. Determine the frequency of each class in the table shown. Do you see a table shown? I do not. It means the table probably did not copy over correctly. Let me bring that up. I'll bring it up in Hawks and show you. All right. So, of course, I would have to provide this table for you. If you were taking this online, it's going to have this table and it's going to have blanks beside it. Let me show you what the table looks like. And I may have to give you just a whole new problem because every time I open this and look at it, it gives me different numbers. Okay, so for number 17, you might want to copy this one down. I'll give you the numbers that we're going to use, but here's the table, and you'll have something like that given on your test. All right, and here are the data items. that we're going to use. So this is really easy because all we do is we'll take a class and we'll count the number between the lower class limit and the upper class limit, and then we'll put that number as the frequency. So it makes, at first it may seem a little overwhelming, like what am I supposed to do, but especially if you had the exported Word file that I gave you, and it didn't have a table there. So what could you do, really? You could make a table, but you may not have chose that many classes. You may not have chose that class width. So that has to be given there. Let's first count how many are between 77.0 and 79.9. So here's one. All right. So I have 1, 2, 3, 4, 5, 6, 7. What I'm going to do to help me, since we're not going to use those again, I'm just going to mark them out so I won't even look at them again. All right. And then 80.0 to 82.9. Alright, so looks like I have 2 of those. And then 83.0 to 85.9. Alright. Those. Mark those out. And now 86 to 88.9. So it looks like I had 3 of those. In 89.0 to 91.9. Just double check to make sure they're in those intervals. So that's what I'll want you to do. I'll make sure that table is there for you, and you'll just count up how many are in each one and put them in there. Number 18, it looks like on that one, the table did copy over. Okay, so we are going to have to fill that out, right? Because we need to use some of the information in it. Like we have to calculate the relative frequency and stuff like that. So I'll copy that problem up here. So it's this same data here. Use that. I'm going to copy it over to my notepad so I can work with it. I counted 21. Let me count again. All right, so I have 21 total. All right, now I'm going to list how many are in this frequency here between 1,002 and 1,081. So there's one. All right, so did y'all get 7 for that? All right. Now up to 1161. Is that 0? I didn't see any. Alright, now up to 1241. So there's 1. So I got 3. Alright, now 1321. Wait, did I miss one? No, I didn't. Alright, that's 1321. 1321. Alright, so that is 4. Now up to 1401. Four there. And lastly, up to 1481. That's 1, 2, 3. And now to double check, you can add these numbers up. It's 10, 10 and 8. 10 and 8 is 18, plus 3 is 21. So I'd always add them all up, make sure you get the same number of total items. Alright, so relative frequency, we're going to take the frequency and divide that by the total number of data items. So 7 divided by 21. So that's 33.3. So we'll just put 33. Percent. 0 is going to, of course, be 0%. I got a lot of calculators open. So 3 divided by 21. So I'll put 14%. Because if it wants it in fraction form, we can do that too. I mean, that was, is that what it says? Okay, step 3 wants it as a fraction. Okay, we can still do that. If it were me and I were, you know, just making this out, I would probably have it as percentages. I'm gonna keep going with what I'm doing, and I'll put the fraction beside each one. So 3 divided by 21 was 14. 14%. We could put the fraction beside it, 7 over 21. What is that? 1 over 3. And then that would just be 0 over 21. And that would be 3 over 21, which is 3 over 21 is 1 over 7. And then that would be 4 over 21. We'll do the percentage for that in a second. 4 over 21. And then the last one would be 3 over 21, which is 1 over 7. So let's figure out, and I know that that's around 14%. Let's figure out what 4 over 21 is. Be just a little bit more. 4 divided by 21. About 19%. So these would be about 19%. And then cumulative frequency. This is 7. This is 0. Well, this is 7, and then if you take for this one, you add the previous one, so it would be 7. And then what happens when I add the 3? I'd get what? 10. And then add the 4, 14. Add the 4, 18. Add the 3, 21. Alright, so now, determine the class width. Remember how to do the class width? We take any two consecutive lower class limits or any two consecutive upper class limits and subtract. So just do the lower class limits. 82 minus, or 1082 minus 1002. So the class width is equal to what? 80. Very good. That was question 1. Question 2, determine the frequency of the second class. 0. Right? Second class, 0. Step 3, calculate the relative frequency of the third class. Determine your answer as a simplified fraction. So they want a fraction, we can give them a fraction. 3 over 21, or which is 1 over 7. Step 4, compute the cumulative frequency for the sixth class. That's the last one. Cumulative frequency should be the total number always, if you're on the last class. That's 21. Alright, number 19, the table's given to us. Determine the relative frequency for the fourth class as a simplified fraction. So how would I do that? You take the frequency, 11. So this is number 19. Problem number 1. And divide by the total number. Alright, and I got 33 was the total number. It would be good if I took the right class. Is that the fourth class? Okay, yeah, that's right. So 11, this is from this right here. So fourth class, 11 over the total number, which was 33. 11 over 33 is what? That's 1/3. That's your answer. Step 2, determine the relative frequency for the third class as a simplified fraction. The third class has 5. That was part 1. Part 2 has 5. It still has a total number, and you can't reduce that. 5 over 33. All right. Number 20, stem and leaf plots. All right, and this is the weights of people in a group. So this is the first part of the number, and this is the last part of the number. So this means somebody was 121 pounds, 122 pounds, 123 pounds. It says, what is the weight of the lightest person in the group? 121 pounds. Okay. How many people weigh in the range between or from 160 to 200 inclusive? So you'd include those end values. All right, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The next one is 202. All right, so from 160 to 200, it'd be 16 people. What is the weight of the heaviest person in the range from 160 to 169? So this lists all the 160s. So the heaviest would be 166. All right, a manufacturing company is shipping a certain number of orders that need to weigh between 193 and 194 in order to ship. Use the dot plot below to answer the following questions. How many orders did the company ship between 193 and 194 pounds? So here's 193. Here's 194. Looks like all you do is just add up all the dots, right? This is 193 and that's 194. Add them all up and you get 15. What was the most common order weight? Well, it's the one with the most dots. All right, 193.8. What was the average weight for this sample? Was the average weight for this sample of orders closer to 193 or 194? You don't even have to do any math. You just see, are most of the items closer to 194 or are most of the items closer to 193? Yeah, you can see these, there's a lot more closer to 194, so the average has to be closer to 194. All right, here is a histogram. What score has the highest frequency? You can see the scores are at the bottom, frequency's on the side. 5, looks like there's 15 there, but it just asks which score, so you put 5 because there's 15 people that scored a 5. What is the frequency corresponding to a score of 2? 13. They must not have studied very much. What is the total number of people who made a score between a 3 and 5 inclusive? So that's going to be 6 plus 8, that's 14, plus 15 is 29. All right, number 23, when I handed this out again, it looks like it just wasn't programmed correctly, so it didn't export over correctly. So I'm going to pull up problem number 23, what it will look like. And it's going to be a little different than this problem. It's the same concept. It just, I can already tell it has a different topic. The one that was given you was about assaults. This one is about burglaries, I believe. So you don't have to copy this down as long as you understand what's going on. I don't think it's very complex. And this is 23. All right, and the first question, oh, that's just one of the graphs, so got to give you both graphs. So there's graph A. Maybe I can fit both of these on one page. And here's graph B. And it says, how many times more burglaries were there actually in year 4 compared to year 1? How many times more burglaries? So I'm looking at this data here. Burglary counts graph A. So these should be the exact same thing, right? I'm looking at them. I think they just have different scales. You see? Graph B looks very misleading. Why is that? See, look down here where this scale starts. By changing the scale, this data is very, very misleading for B. All right. This would be a way that maybe a city official or somebody could present this in the newspaper, and people say, oh, year 5, wow, so many less. Look at year 4 whenever so-and-so was mayor, and now look at year 5 now that I'm mayor of this city. Look how many burglaries we've had. I mean, it just makes it look like it's not even maybe a 10th or so, or maybe a 8th as many. But actually, you got 210 in year 5 and 290 in year 4. Now, was there a drop? Yes, but it's definitely not as little as this is making it out to be. All right, so look at year 4. How many burglaries? We can tell by looking at graph B, the exact number is 290. You can't really tell at graph A. So in year 4, we had 290 burglaries. Now, what about year 1? Year 1, this looks like it's pretty close to 250. Can we tell here, year 1, we can actually tell it's what? If it's between 250 and 260, it's 255. So we do need both charts to be able to tell exact numbers for year 1 and year 4. It's just that the second chart is very misleading if you try to take it just for what it shows. All right. So if we want to know how many more times, or how many times more burglaries were there in year 4 compared to year 1, then we would take the bigger number. Let me see. Bring up our calculator. What if we take the bigger number and divide it by the smaller number? So we can see that there were 1.13725 whatever times as many burglaries in year 4 as there were year 1. The problem asks us to round to 2 decimal places. So what will it be? 1.14. That's your answer on that one. So 1.14 times as many burglaries in year 4 as year 1. All right, here's the second question. So we have those two graphs. Step 2 says, which graph do you feel better represents the data? Graph A represents the data, neither A or B, both A and B, or graph B? Which one do you feel like is not as misleading? Graph A, because graph B starts at a different scale. So that's a way to mislead people. So graph A. So there you go. Does that make sense? Kinda, sorta? Again, we don't like misleading data. Alright, number 24. Given the data in the table, which graph best depicts banana prices? And you see what the graph looks like here? So I might have to copy this over because the graph wasn't included. I'll make sure on your test that it is. Don't worry. And again, if you were taking this online, all the graphs and tables and everything would be there for you. I'm going to give you an example and show you what I'm talking about. Alright, so in this example that I'm about to show you, it doesn't show bananas, it shows bread, but it's the same concept again. That's the good thing about working the practice. Sometimes you'll see different examples, but it's the same stuff. Price of bread per pound in February. Alright, and then the choices are, so we have this one. I'm going to make it a little bit smaller. We have this one here. So these are all choices. This one here. And lastly, this one here. All right. So what we want to do is we want to look at the years and the price per pounds. Look at the scales, and we want to know which graph best depicts the bread prices over a 10-year period without representing it. I mean, misrepresenting it. All of them probably represent it pretty well, but which one does it the best? So which one? A? You think A? So let's think about the prices. So they went from $1.32 to $1.26. So that's not a whole lot in money, right? It's not a whole lot. So any of these graphs that show big changes, probably are there to mislead. So I would think that this one and this one will be out then, because they show big changes where it's actually not that big of a change. This one, but now if we look at these two, this one has all this space up here that's not even being used. So it really doesn't make as much sense. So it would be this one right here would be the best representation. I'm not saying that none of them are wrong. It's just that, you know, that top one there has a lot of space down here not being used. This one has a lot of space up here not being used. Between these two, they're kind of close, but it makes it look like there was a huge jump, like maybe dollars, even though it's just cents. It makes it look like there was a huge jump from that year to the next year. So that one, I guess, is a little subjective, kind of the way that you see it. So I would understand. I'd probably take more than one answer on that one, because that's a little tricky. And then the last problem, problem number 25. Which of the statements about the following graph is true? All right, so A, the y-scale is too large for the data. B, the y-scale is too small. Well, it doesn't seem like that's going to be a problem. C, the y-scale is appropriate. So the correct answer was that it's appropriate. I guess there's not too much up here. There's not too much down here. So it would be just about right. Again, that's a little the way that you see it. I don't think it's very misleading, though, at all. All right.